Hello and welcome to another quick and easy math video. Curve sketching using second derivative. Considering a cubic function like 2x cubed minus 24x, it's easier to sketch the curve using the second derivative provided the second derivative is not too complicated. Now we have done other videos to show how the turning point or the critical values can be determined using the first derivative, because the first derivative at the turning point is equal to 0. So we find the first derivative with respect to x. 2x cubed is, bring the power down, 6x squared minus derivative of 24 is negative 24. That's equal to 0. We solve it mathematically and we arrive at two x values, positive 2 and negative 2. Now we substitute this x value back into y to find the y coordinate of the turning point. So that's negative 32, and we use negative 2 substitute back into the equation for y to find the second turning point, which is negative 2 and positive 32. Now we have two critical values or critical turning points, a as positive 2, negative 32, and b as negative 2 and positive 32. But we do not know which one is the upper turning point and which one is the lower turning point, or which one's the maximum and which one's the minimum. For this, we use the second derivative. So we differentiate the first derivative again. So 6x squared, bring the power down, 6 2s are 12, x to the power 2 minus 1, which is 1. So 6x squared differentiated gives us 12x. Negative 24, differential of constant is 0, so we don't write it. Now we are trying to find what the nature of the second derivative is at the critical values of x, which is positive 2 and negative 2. So substituting positive 2 from one of the turning points into the second derivative. So we're finding y double dash at x equals positive 2. So 12 times positive 2 is positive 24. And the condition for a maximum or minimum is that when the second derivative is greater than 0 or positive, then it's the minimum point. So the turning point A is in fact the minimum point. And we take the x value from the second turning point b, substitute it into the second derivative. So we're finding y dash of negative 2. So 12 times negative 2 is negative 24. If the second derivative is negative, then it's a maximum point. So it's very easy to conclude that A is the minimum point and B is the maximum point. Now, in order to sketch the curve, we have to complete all the essential points, that is the x-intercept and the y-intercept. For the x-intercept, we'll make y equals 0. So 2x cubed minus 24 equals 0. 2x is common outside, so we factorize this to get x squared plus 12, negative 12. So this, applying the null factor rule, we know 2x equals 0, which gives us x equals 0, or x squared minus 12 equals 0, or x squared equals 12, or x equals square root of 12, positive, or negative square root of 12. So the y point for all these 3 points, the y value of all these 3 points is 0. The x value is 0, square root of 12, which is 3.5, around there. Negative square root of 12 is negative 3.5. So we have the other 3 points needed to sketch the curve. We go and mark all the points there. So A is the minimum, positive 2, negative 32, positive 2, negative 32. It's not very accurate. Negative 2, positive 32 is the maximum, negative 2, positive 32. And we have the x-intercept, which is 0, 0. X-intercept 0, 0 is point C. D is 3.5 and 0. 3.5 and 0 is D, and negative 3.5 and 0 is E. Now the y-intercept is x equals 0. When we make x equals 0, y equals 0. So the y-intercept and one of the x-intercepts are exactly the same. So we can complete the curve like that.